Hey folks, welcome. And so, hi, I'm Greg, for those that don't know me. I thank you for coming along this afternoon. I know at any of these events there are a large number of sessions that you could have gone to, and so I'm very pleased that you came along. So look, first thing I want to point out in this is that this is a fairly opinionated session, right? And so I'd have to warn you in advance that you might not agree with everything I say, right? And in fact, I think it's probably highly likely that on any topic I talk about, there'll be somebody in the room violently opposed to the idea. But anyway, I can only tell you that this is what I think. I put a baseball umpire there in another life, things that people probably don't know about me, but I used to spend my life umpiring baseball, and so I'm sort of very used to having, shall we say, strong discussions with people, so it's all good. But look, it's also not just my opinion. Now, I've formed a lot of these ideas on things that I've seen over a lot of sites over a long period of time. I've worked with SQL Server now since about 1992, so it sort of feels like forever at this stage, and worked with a very large number of sites. And in the last number of years, a big focus of what I've worked with are software houses who are building applications that run on the SQL Server platform. And there's just a number of things that I just see time and time and time again that I just want you to think about, all right? Even if you totally disagree, I want you to go back and think about these things. And also, it's not just my opinion. We sat on the MVP forum, there's about 300 odd SQL MVPs, and had a discussion on this a couple of months ago. And these were the things that tended to bubble to the top of, people going, oh yes, I just see this again and again and again. And so look, feel free, just use or disregard as you see fit. So look, where I fit in, so a data platform MVP, which what we used to call a SQL Server MVP, part of the RD program along with Adam and Neil Rudin and Oren and Pete Calvert in Australia, and do a bit of writing and things like that, but head up SQL Down Under. Mostly I'm focused on every day working in and around SQL Server. Look, there are 6 specific areas of advice I want to talk about here, plus a number of things that are just sort of more general design advice. So look, the first is what would have to be code smells, right? So I spent a lot of time getting dragged in or going into sites and things aren't good. That's why we're there in the first place. And usually when I look at a lot of these applications, there are a number of things that are problematic. First is that they usually have major performance problems. Usually the product is too slow to ship. Usually the ship date was 3 weeks ago. And so it's not something where they have time to still even fix it. And then you often look, and I think there are fundamental architectural issues in what's done. And it's then very, very hard to have that discussion. And so look, the first of these, there are just things that if I look at the code and I see a bunch of these, it's an issue, right? Straight up. And so if you find yourself making extensive use of cursors, then you are already in the camp where you're probably not using the product the way it's meant to be used. Now, there are places where you'll use cursors. I use them all the time in things like tools I build or utilities, those sort of areas, but they're not things that I'd use in standard processing of most data. So they always tell you about trying to think in terms of set-based operations. That's very much the case. Another big one there is temporary tables. So if I see a whole lot of cursor-based code, particularly if it's mixed with a whole lot of temporary tables, that's another sort of red flag in terms of what's going to happen here. So what often happens when people are building the code, they tend to think fairly procedurally. And so you often see code where what people do is they go and select a bunch of rows, throw them into a table or some sort of temporary table, then they go and process it, select the rows back out the other end, and then drop the temporary table. 99% of the time, that whole thing could have been a single select, right? Now, why that matters is that every time you go off and sort of create like a temp table, or if you use a table variable, then you're going off and materialising or persisting that data out into TempDB. And TempDB is a shared resource. It's not somewhere you want to be just endlessly hammering with data. It will quickly become an issue for you in most systems. Another common mistake is I hear people talk about table variables and I hear the words like in-memory tables, these sort of words. They're not, right? So a temporary table is basically the same as a table variable. The two are really close to identical. The difference between them, table variables are scoped to the batch. So when you issue a batch of statements, they're gone at the end of the batch, right? Another big difference is they have a different transactional behaviour. So in the case of a temporary table, if you roll things back, the temp table rolls back as well. But the values that are in a table variable don't roll back. But some of the advice, and some of it unfortunately has come out of tools like the best practice analyzer, say things like, they see you using temp tables, they say consider replacing it with table variables. Now what they're worried about recompilations, right? And so if people have code that's recompiling all the time, then what they figure you can do is replace the temp tables with a table variable. The downside of that is that, of course, you get lousy query plans, right? Now, the reason you don't get the recompiles is that they don't have statistics and things for those temp table variables. So no matter how much it changes, it's not going to cause it to recompile. But that's not a good thing, right? That just means that you're going to have this sort of fixed plan, absolutely no matter what, sitting inside there. They have a little bit of cardinality information, but that's it. Whereas at least if you use a temporary table, by comparison, you have stats, right, on that, and you can also do things like create indexes that will help it out. But that's if you really must go off and do that. Extensive use of dynamic SQL is another one. I find people that just endlessly, there are good reasons for doing dynamic SQL. If you're doing that though, one of the things you need to think long and hard about is the security context in which it runs, right? And so if you're using dynamic SQL, it breaks the chain of ownership in terms of objects. And what you can do about that, since SQL Server 2005, is I can create a bunch of code and I can say with execute as and override the security context in the middle of that block of code. That then stops it breaking the ownership chain. And so you can have much better control over that. Where what I see is I see people just executing it, and as long as their apps are like a DBO user, then all will be good. But the minute you start using an appropriate security structure, it's not going to work. Triggers. If I see sites where they just endlessly build all the logic and triggers, it's just not the way to do it again, right? In fact, I had someone outside yesterday ask me did I know what the nesting level was for triggers? Okay, now it is 32, but this is not a question you should ever ask, right? Because you are heading down the wrong path the minute you ask that. I've been into sites though where they've implemented every single piece of logic almost inside a trigger. This is not where you want to be. They're diabolical to try and debug. And what happens though is that people think about sort of event processing, and because the initial thing was an event, they then start thinking everything else has to be sort of trigger based. And so to give you an example, I saw one where they had an identity system. The identity system updates a table in the local application. They have no control over when that occurs. But when a change occurs in that table, they needed to then go off and modify a whole lot of other tables. Now, you can do that, obviously, with a trigger, but then when it got to the next table, they then had a trigger, well, if that changed, maybe we're going to do something else, and it just cascades, and we've got one after the other, that sort of logic. What you need to do instead in those sort of scenarios is that when the first trigger fires, you need to just drop the data in a queue, like Service Broker, and then pick the data up out of the queue using a normal proc or something, and then go off and do the rest of the work. And at least that way you can stop the queue, so people could do maintenance. You don't have to have that first table, or your system's not tightly coupled with the one that's making the changes. And also, you could also inject messages into the queue to do testing on your code and so on. It just makes a far cleaner way of getting around this. But one of the ones that's probably the worst offender is the use of T-SQL scalar functions or multi-statement table-valued functions. These are just poison. And I wish they weren't in the system, but they really cause major problems. Now, I want to show you why. All right, so I've got a little bit of code here where I'm selecting from a products table, just go off and get some product detail. And if I look at the query plan for this, all it's doing is sort of just reading the table, right? So this is straightforward. Shows the cost as 100, so that's all good. Now, if I said, look, I also want to have a value from that table pass through some sort of function, I've gone with a very simple one here where I said, look, I'm going to have a function that says, is this a bulk item or not? And all I'm going to do is say return, if the outer quantity that's passed in is greater than 24, say yes, I'll say no. And so if I go and create this function, then I call that in here, then obviously it sort of works as I expect, and I get back whether it's bulk or not. But what's not immediately obvious is I've just caused myself potentially quite a bit of a performance problem. Right now, it seems sensible to be able to use functions like that to encapsulate or abstract away your logic. Unfortunately, it just doesn't work properly. And so if we look at the query plan for that, notice there's now two sections to this. The first section still says clustered index scan cost 100. And the second one down here, notice is the execution of that function. And it shows it as 0%, but it's not. Right? They have no way of estimating it at all. But what you've just done is you've created a scenario where it's now going to go off and call that for every single row as it's passing through the table. And that's insanely painful. And those sort of functions will cause you real difficulty. Now, the alternative, if we had simply put that case statement directly in the code, I know it's not great abstraction-wise, but notice we're right back to where we were in the first place, right? So this could be done on the fly, on the way through. I know a lot of people seem to make half their living just by removing T-SQL functions out of people's code, right? Simply because of the effect that ends up happening in performance. Now, there are other alternatives to that. So, for example, if I nuke that function and then go and build an alternate one that's a table-valued function, so I could say, look, returns table, and then say return case when that. Now, a little bit ugly, but the difference is if I did that, I think I did that already, and if I cross-applied that function, it's still a bit painful, but notice the plan that's produced is actually the same plan, where it's just going to dive through. It knows it's got to do that for every row, but because of the way the function was structured, it's able to inline the code back into the original query, right? And that'll make a substantial difference to how that works. All right. Okay. Now, next one I want to mention are just some specific code smells. One is if I see this in code top 100%, or I see people expecting tables and views to have an order, and also there's a whole lot of scenarios where people use not in that are problematic. Let's have a look at those. And so this one here, I see this all the time where people have attempted to create something like an ordered view. And so they say, look, create a view, ordered products as select a bunch of things, and then they try and go order by product ID or something like that. And of course, the message that comes back says not going to happen, right? So it says order by you can't use in views, inline functions, derived tables, subqueries, CTEs, and it goes unless top, offset, or 4XML is in the query, right? So what people do then is they go, oh, okay, no problem at all. So they then go select top 100%, right? And pop that in. It goes, yeah, cool, no problem at all, right? Now, when I test this, invariably, right, it looks like it's in order, right? I mean, it absolutely does. But it's not, right? So what's going on here, through a quirk back in SQL Server 2000, it would always return that data in order, right? It would actually do that. But that's not the point. There is no such thing as an ordered view, right? Full stop in SQL Server. And so the problem with that is that what ends up happening is it uses the top to determine, it uses the order by to determine the top, and then it just returns the rows in any order anyway, right? So it is using it, but it's using it to implement the top. Now, where you come unstuck is the minute you start having multiple processes and things like that. It's happy to just return the data in any order at all once it knows what's going on. And people think this is broken, but it's not broken, right? It's just there is no natural order. Now, if we look at, as I said, if I select from that, it might appear to work, but it doesn't really. Now, I also want to show you a thing around not in. This is another one that tends to cause a lot of problems. And so if I just count the number of products I've got here, let's come back. So I've got 68 products in the list. If I said go and select the products where the product ID is in 1, 2, 3, or 4, then no big surprise, I get 4 products back. And if I had said not in 1, 2, 3, or 4, then no surprise, you'd expect to get 64 rows back, right? And totally as expected. But where it becomes tricky is this. And so imagine I said, look, select from the products where product ID is in null, comma 1, 2, 3, 4. Yeah. And that returns 4, right? But if I do this with not in, do we know what it returns? The answer is none, right? Now, so basically what's going on is it doesn't know if it's in there because it considers that an unknown value. And so where this causes pain is what you strike occasionally is people using not in, but they'll have some sort of sub-select or thing here which could potentially return a null, right? And that's when you sort of run into an issue with that sort of thing. So anytime you have a not in, you've just got to be really, really careful in that the sort of query or the whatever is returning the list could not possibly be something that would return null instead. All right. Next one, loving the data is a big thing. Now, there was an interesting survey I saw the other day. And it talked about it was an Ubuntu forum at Quora, and they asked developers what they found hard about their jobs. Number one thing was only 2% of the time was designing solutions. So that was actually the easy bit. Writing tests came next, again fairly easy. Documentation was a little bit harder. Implementing things they didn't agree with started to get a bit trickier. Trying to understand somebody else's code, yeah. Dealing with other people was sort of high on the list. Estimating time was problematic. Explaining what they do to other people was a major challenge. But the thing they said was 48% of people was the hardest thing they ever do was naming things. Now, clearly this is going to be an area where people have very, very different ideas, right? So there is no right answer here. Now, I have a personal preference on some of this, but yeah, again, you may not share that view. The first thing is that I tend to avoid prefixes. Now let me tell you why. Is that they're really good when they first start and then life intervenes. Okay? I'll show you an example. Even SQL Server, if you look in the master database, they have stored procs and extended stored procs. Now, when they first designed these, it was all clean, right? And stored procs, the system stored procs, were all SP underscore something. And the extended stored procs were all XP underscore something, right? But now notice, if you go to the bottom of the list of system stored procs, there's a bunch of XPs in here, right? And of course, the reason for that is they changed how they were implemented, but they weren't game to change the name because people already had dependencies on them, right? And if you look at extended stored procs, most of them are XPs, but now the whole top of the list is full of SPs. So, which are the ones that are meant to be the system stored procs. And so, same thing applied, right? Now, this is the reason why I go into so many sites and they have things like tables named V something, you know? Or they've got views named TBL something. And it's like they've interchanged tables and views, but they weren't game to change the name, and so on, right? This is problematic, right? So it can start out clean. If you look at most people doing .NET coding, they've got long past using those sort of, Hungarian prefixes and things. People still do it, inside SQL Server. I don't understand that. I think, personally, it's a mistake. The other thing that tends to happen is if you look at where people design some of their databases, it's really, really common. I'll see a whole lot of tables, and every table's got the same prefix, right? And so if that's the case, really all you're trying to do is group all those tables, then probably that should be a schema, And so, since 2005, that's been an option. If you look at a lot of the Microsoft examples, I'm not overly fussed in how they've done it, but if you find yourself just endlessly repeating the same value the whole time on a bunch of tables, really, that's probably not a great idea. The other thing is, I see this in a lot of BI systems as well, and unfortunately the BI guys still seem to do this. They'll have dim something, fact something, fact. If you're going to do that, just have a dimension schema and have a fact schema, I'd rather go fact.sales or, dim dimension.customer rather than going dim customer, because you're going to end up in every tool from that point on spending your whole life stripping out the prefix anyway, right? So the thing is, you may as well head down that path. Now, the other thing is, obscurity isn't some sort of virtue, right? I see people just with some of the most bizarre naming things. This one here had me going. These were the names of the table. So like ST was students, DF was families, SF for staff, SXAB for half day. Like, I got no idea. So, I don't even know what language that's probably meant to be, right? I mean, just kind of beyond me. But the thing is, in the end, you may as well be just really clear with things nowadays, right? I have the same argument with the SQL Server team as well. You might have noticed in SQL Server 2012, they added new functions, like EO month. And I just look and go, why not end of month, Like, really? And in the same breath, they added a function called date time part from offset, or date time offset from parts, like, okay. So, like, spell things out, be clear, in what you're doing. It really is helpful. I think the worst scenarios I've seen of that are, I was at a site a little while ago where they'd used GUIDs to name all their tables. That takes a special kind of style to do that. What was cool as well is they had about 10,000 tables in the system as well. And of course, if you try and read a query plan, it really is something to behold. If you've done that, because I can't remember one, let alone a full set of them. That's just not even possible. I mean, there are people around. I often mention, actually, one of the best little documentaries I ever saw, there was a thing called Superhuman: Genius. It was a BBC documentary. And what they had is they had gone around and found people that had special abilities, and they'd worked out who had done the best job of commercialising their ability and who had done the worst. The best commercializer they found was a young girl in the Ukraine who paints, and at the time they were selling prints of her paintings for something like $1,100 a print, and she was selling thousands per month. And so, she was 14. So she was like the best they found. But the worst they found was the UK memory champion. This guy just had the best memory on the planet. They had a competition memorising bits, ones and zeros. And he won with 4,633 bits. There's something peculiar about that, right? The ability to do that. They get a deck of cards and shuffle them, and 19 seconds later he can lay out another deck in the same order, right? In fact, they can give him 9 decks of cards, all shuffled together, and he can lay out 9 decks of cards. That's super impressive. But the one got me most is they took him to a supermarket and they walked around picking up items and showing them to him and put them in the trolley. And when he got to the counter, I thought he knew the price, but he knew the barcodes of everything in the trolley. Now, but he was broke and he was penniless. They didn't have a job. They were trying to work out what he should do for a living. So I don't know. He does what computers do. Anyway, and so look, data types, you need to use the right data types. You certainly don't want to be still in text, n-text, image, any of those sort of data types. I do see quite a lot of use of money and float. Now, money is a tricky one in that it was an old Sybase type, and it's still in the product for backwards compatibility reasons. And of course, it's really hard when somebody first goes to use the product and they think, I want to store, money, and they see there's a money data type. I can totally understand, why they might decide that's a good idea. It's a fixed 4 decimal place thing. It really isn't the right thing to be using. You should probably be using decimal for that, determining what the appropriate, it's an ANSI data type for a start, but you should be determining the right precision and, of course, working out all the time how you actually need to do the rounding appropriately. Picking appropriate lengths is an issue. One of the ones that I run into here a lot is people just tend to pick big numbers for things like strings. That's not a great idea, right? For example, I was at a site recently where they were storing email addresses, and so they thought, let's make it big. They just went like 1,000, right? The problem with that is in the next breath, they say, I want to index that, right? And we have things like a 900 byte limit on components of an index. Suddenly a problem, right? This sort of thing. Yet, if you're ever storing things like that, of course, the right answer is go and look at the standard and find out how big email addresses can actually be, right? I mean, there are standards for these things. Don't just guess some gigantic number. Another big one is that strings are just super slow to sort. It's hard to maybe initially imagine, but if you're just comparing 2 numbers, a system can do that super fast, right? I mean, just really, really fast. It can do that. But in something like SQL Server, the problem you've got is whenever you store any sort of string value, you've got all of the collation rules associated with the collation it's stored in. So every time you go, is this string even just, is A equal to A? It's got to apply rules going, do accents matter? Do, all of the different things that does case matter? It's got all of this logic, and that's one character, and then it goes to the next character, and then it goes and applies all of this sort of stuff again. It is a big job comparing strings. Now, if we lived in a world where performance doesn't matter, fine. I get no issue with that. But the thing is, if you string your whole system together based on strings, it just won't perform at the same level as if you'd done that. Now, another common thing is where people have used GUIDs to string the whole system together. Now, again, if you look at things that are going to join, it's a 128-bit integer, basically. Now, it does join reasonably well, but we're still working with 64-bit machines today, and so a 128-bit value is not that trivial to compare compared to a big integer even, right? Now, and curiously, I was at a site recently where they were replacing the use of big ints because they were worried about running out of them. That's not going to happen, right? And yet somehow they're bizarrely worried about that. I saw a thing in the early 90s where they said, if you've got an 8-bit machine and you put 0 in it and you put it in a loop, you'd overflow before you could blink, right? If you did that with a 16-bit machine with 65,000 odd ops, that's still a blink of an eye. 32-bit machine, sort of 4,000 million ops, yeah, you can sometimes notice that. But on the fastest machine available that day, a 64-bit value was 350 years. Just doing nothing else but adding 1 to get to the top value. Now, machines are quicker now than they were then, but we're talking about a seriously large number, right? So it is very unlikely. I think the product group told me a while back they had run into the first person who'd ever exceeded that for an identity column, right? But again, that would only be where they have some bizarre increment sitting on top of that. Now, another thing I see with that is I see people also prefer to start at the biggest negative number with the idea that at least that way they get to use the entire range. Now, I understand the sentiment, but for the reason, like, I'm not good with GUIDs, I'm not great with massive negative numbers either, right? And the other thing, in a more practical sense, is you can imagine the difference in compression when you start using things like row compression is massive when you start talking about a big negative number as opposed to a much smaller positive number, right? The two don't work the same. Now, float is another sort of special case. And of course, this is the one that usually it's the sort of the newbie mistake. But I see all the time people coming from particularly Java backgrounds and so on, where they'll often end up using float for storing things that are decimal values. So, for example here, if I said, look, declare value float 0 while float is not 10, print out the value and then just add 0.1 to it, right? And so reasonable logic would say, it wouldn't run forever, but of course it does, right? And if we look at that, we're going to scroll down. Eventually, somewhere here, we're going to see 10 in the list, right? But the thing is, it never equaled 10, I mean, the thing that prints it out, rounds it off, I mean, yes, it does. But like we have recurring fractions in decimal, like a third, the same thing applies in binary, and 0.1 you can't store, right? And so you don't want to be building a system where you can't store 10 cents properly, So these are the people that tend to have columns of numbers that don't add up, or they're out by a cent, or these sort of things. You don't want to be there, right? Use the right decimal data type and round appropriately. The one sort of exception to that is some of the scientific things where people are doing work on that. There are a couple of scenarios where that makes sense. Maybe some latitude, longitude, things like that. I've got a spatial session tomorrow at 11:30. If people have got time, come and have a look at some spatial stuff. Now, look, constraints matter as well. This is another one where people look and say, this is only an issue for the application, and they don't see it as an issue for the database, but that isn't the case, right? Now, the first thing with constraints is that it makes sense to just do that in the app, you would think, but almost every site I ever go into, there's a whole bunch of apps touch the same data, right? So you don't want a scenario where every one of them has to play the same game for the data to end up correct. That's not reasonable, right? The other thing is there are areas where they have a performance impact. Now, to give you an example, if I have a set of data where I've got, say, a state code, and I've got a bunch of sales, and in there there's a state. If I then have a table that says, here's my state code, here's the name, the question is, what do you do designing that table? Or a country, same sort of thing applies. Now, what I typically see is things like this. They'll have some sort of states table. They'll say, I've got a state code. They'll mark that as a primary key if I'm lucky. And then they'll have a state name. But when you look at this table, guaranteed this thing will be unique, right? But people won't mark that as unique, right? This is another very, very common mistake. And so you think, well, what does that matter? Well, where it matters is if I'm going through adding up a bunch of data, and I need to summarize it by state, what you would do is, if you were writing the code yourself, is you'd go through and aggregate it by the state code, and then at the end, you'd join to the table to get the name, right, for all of the total of the aggregates. But that isn't what happens, right? So invariably, people using query tools and things like that, they won't say order by state or group by state code, they'll say group by state name, right? And the difference then is that SQL Server has to get every one of those sales rows, join it to the state row, produce the entire set of data, and then go and sort the whole thing by state name, which is insanely painful, to then be able to throw the data out. If all you had done is put a unique constraint on that column, then it's clever enough to know that it could just aggregate by the code and look the name up at the end. And the only difference is whether you have a constraint sitting there on that column. Okay? So these things can have a performance impact. And so another thing with this is that where you have things like default constraints, notice that if I go to drop the column, the thing that it says is, hey, this thing's got a default constraint in place. Note the horrid name that it picks for this. And then, of course, it says, hey, that's not going to work because you need to drop it first. But the problem with this is you don't know the name of it, and you've got to write code to go and find the name to be able to drop that before you can sort of do work on the column. Now, where this becomes a real pain is you've shipped code out. Now you're wanting to change the default or drop the column or do things like that. You've now got to write code because you have no idea what the default's called at all the different sites. You've got to write code to go and find that default, then go and nuke the default before you can go off and do the column. It's just a pain in the neck. Whereas if you had named the constraint in the first place, then it just becomes trivial to go off and do that. The other thing I like with this, so instead of that, so we could drop this. We could do this sort of thing. So first up, we could name the constraint again. What I like often with unique constraints, it's not so much of an issue with the single column ones, but I really quite like with things that are like unique across multiple columns, that the name actually includes the message that tells you what went wrong. And so that way, if I create this, and let's drop a few states in, and then if I try and do something that causes a problem for that, at least I'm going to get a message back that contains English telling me that this thing is actually the problem, right? Something like that, rather than some obscure name coming back as part of this. So anyway, I've found that works really well with things like unique constraints and that sort of thing. Another one that's important is foreign key constraints. Again, you need, I don't care what your standard is, but you need to have some convention that says this is how I name foreign key constraints. Because again, I run into sites all the time, where it's just picked some random name. Now, I was at one a little while ago where they had triple created all their foreign key constraints. So if you look at a query plan, every time you change something, it would check, it had 3 checks to the table, like to be sure, to be sure, to be sure. And this was all simply because they just ran the script. Somebody else thought nobody else had run the script and so on. And if you don't name them, it'll just happily keep creating them. It's the same with a lot of the indexes. Again, whatever the standard is, however you do it, just again, think about what that might look like. Another one is the don't be a lousy neighbour. So locking is not something you need to avoid, right? And so what I find, again, if you look at systems that where people haven't really thought this through too much, just trying to say, look, if no lock is the best answer you're coming up with, it's probably the wrong question you're asking, right? The thing to understand about no lock is you are really simply giving up all concept of consistency in your data for the purpose of avoiding any sort of locking. Now, there's still locking going on. I mean, there's still schema locks and things like that. You try and change the table while you're in the middle of it, you'll find out what happens. So there's still locks and things going on, but what you're doing is you're throwing away the consistency on that behavior. So for example, if I'm got a query that's powering its way down an index and somebody's taking rows, the Halloween problem, they're taking a row from behind me and putting it in front of me, I'm going to see the row multiple times, potentially. If they take a row from in front of me, put it behind me, I'm going to have rows I don't see at all, right? If somebody starts a transaction and I get the row and they roll back the transaction, there I've got the transaction. It's very hard to explain later when you have a report where you've got transactions that never existed in the system on your report. That's hard, right? Even trickier to explain why you've got a row missing or why you've got multiple copies of the same row, things like that, right? It's not a panacea. It's safe if you're talking about data that has any possibility of being changed at the same time, then it's kind of safe for that. Where it makes good sense is if you're dealing with read-only petitions. That sort of thing actually is helpful in that area as well. But it's rarely the right answer. And so what you need to do is sort of think and learn about the isolation levels that are going on in SQL Server. There are a number of things that are much better options that have appeared in the last few years, particularly since 2005, that'll let us get around a number of these problems. Most of the time when I see no lock, it's because people just have tons of blocking behaviour, and then usually they end up with a whole bunch of deadlocks. Now, most of the time with the deadlocks, you cannot avoid them, right? I mean, you cannot totally avoid them. You can do things to minimise the situation, but I'll sort of mention later, you need to deal with them when they happen, right? You can't just plan them out of the system. That's not going to happen. And so in the case of concurrency, you need to understand the different isolation levels and how they work. Try and make appropriate use of things like snapshot isolation. Have a look at read committed snapshot at the database level, which is at least going to take your read committed selects and turn them into read committed snapshot selects instead. Most sites I'm at, when you turn that on, you'll find that most of that blocking behaviour disappears, okay? Because you're starting to work with versions of the rows instead of working with blocking and locking as a mechanism for sort of getting consistency. Now, breaking up. Connections are a pain, right? Now, the most common mistake I see in this area is I see people building systems that are unbelievably optimistic. You know? You're moving into more and more systems where that is just not the right assumption to be making at all. You need to plan for failure every single time and then think, what am I going to do when this goes wrong? Okay? And so in the case of, I mentioned things like deadlocks, actually I mentioned here a few while we're at it, there are scenarios that come up that you just simply need to deal with. And so if you get deadlocks, once you've done all the things you can to minimise the number of times that occurs, what you need to do is deal with the situation. Right? Now, most of the time, that just means back off for a short period of time and have another go. Right? But what it means is the way you put data into the database isn't start the transaction, do the work, commit and hope for the best. It needs to be more logic that says, while I haven't committed that chunk of data, let me go off and try and slip it into the system. And if it falls over for one of these reasons, let me back off and try again. Right? Now, deadlocks are one. Errors 823, 824 are disk checksum errors. And you think, well, how on earth is that going to... Because obviously the disk subsystem, you think, has tried its life out before it gives up. But when you get into more highly available systems, they have things like automatic page repair. You know, I think it's the wrong name. It doesn't actually fix anything. But what it does is it'll go off to the replica, get a copy of the page, rewrite it in the primary, and if you read the data again, you'll get the data, right? And so 823s, 824s, some 825s, these are things you need to think about, how would I handle that? If you get an 829, an 829 says page recovery in progress. So that says we're in the middle of trying to recover some of the data that you're trying to read, right? That's another hint. Maybe you should back off and wait a minute. If you're using snapshot isolation level, as opposed to read committed snapshot, I mentioned before, it can throw an error 3960, which is the new concurrency violation. And so that one, again, you need to think about how would I deal with this. But the other thing is, as I said, the connection itself could just simply fall over for some reason. Now, it could be network dropouts and things, but it could also be some highly available system failing over, right? I go into enterprises all the time where they've spent an absolute fortune on highly available equipment, and yet the minute it fails over, as it is designed to do, every app in the building breaks. Now, that's not reasonable, right? Could you deal with the fact the server disappears for 30 or 40 seconds? Of course you can. But it's not going to happen by accident, right? You have to have thought about how I would do that in code. If you do that, then your code suddenly becomes so much more reliable. So things like failovers, stuff like that, network dropouts, all sorts of things suddenly become something you can cope with instead of your code just exploding, when this occurs. All right, so try again. T-SQL. There's a lot of stuff changed since 2000, right? Yet what I see is an enormous amount of stuff where people are still writing code very much the same as they did in 2000. And look, I understand that, right? The worst is probably try and get yourself out of old-style joins. Old-style join syntax, you don't want to be doing anymore, right? Very simple differences. So look, between the two, right? So if you look at how people would tend to write code before where they'd say select from some pair of tables, and in the where clause, they're going to have the join criteria and the sort of filtering criteria. The committees looked at that and went, that's a mess. So what they did is they said, look, separately break out how the tables are joined and then keep the filtering stuff separate, right? And it's much, much cleaner to do that sort of style of thing. There's code generators in Microsoft's own tools that still generate the old syntax. I won't kid you that, right? But it's not where you want to be. You want to be very clearly doing this. The other thing is it allows you to very clearly specify the type of join that you're looking for. Where again, in the older one, you had to kind of derive that from what was going on in the query. Yep, sorry. Absolutely. Oh, sorry. The question is, has that got anything to do with performance? No, it doesn't. Right, so it's absolutely 100% readability of the code. Yep. Look, another couple of T-SQL issues I come across all the time is I see people using count instead of exists. That's not clever, right? So if you need to know if a row exists, don't go counting the number of rows, right? At least if you use an exists, it knows it can bail out the minute it finds one, right? Whereas if you ask it to count, unless the optimizer is clever enough to work out that that's all you're trying to do, then it's going to go and count all the rows, right? And that's probably not a great idea. Select asterisk, obviously, is rarely a good idea, right? So it's very, very common to have unbelievable amounts of data getting selected and simply not being used. And what can be worse about this is that you might have a query in place that does what you want, and then somebody will add additional columns to the table, perhaps large ones, and then all of a sudden you're retrieving those as well. The other big problem with that is that invariably what it'll lead to is a scenario where somebody tries to help you in terms of indexing structure, you will have defeated almost any attempt they have to avoid lookups and things in the table, right? So simply by doing that. And so you don't want to be in that territory. Distinct. I see people all the time who they can't work out the joins. They haven't got it right, so they'll just whack distincts at the top, right? Somewhere in there's something coming back duplicates, I don't know why, right? So, okay. But not a great solution, right? Because in the end, you're doing an amazing amount of work and then sorting the whole result set at the end to then try and throw out try and work the joins out, right? Union versus union all. I see people regularly using union when they probably should be using union all, right? So union all says get both sets of rows and just return them, right? Many cases, that's what you want. But if you just say union, it's going to get both sets of rows, then sort the entire lot, and then do a select distinct over the top of the whole thing, you don't want to be doing that, right? If you know there's nothing there that's going to be the same in both sets. All right. Performance matters, unfortunately, at the moment. One is that if you're using staging data, where you really don't care about the data integrity, and if the process falls over, you're going to start and do it all again, you may consider just a completely separate database for that. And also, you might decide that database is in simple recovery. So at least that way you're not pumping the transaction log full of all of these things that you're doing for the staging. I also see scenarios where people think they can't optimize because they've got really generic queries. Now, the answer to this is you have to do some sort of measurement or instrumentation to find out what's going on. I remember doing some work at a flight booking mob in Brisbane one time, and they had a proc where they would take a ticket number and half a second later it would return all the details of someone's booking. And then somebody said, look, can we look it up by email address? And they said, okay. And so they added that in. Then somebody said last name. And then somebody said, it just went on and on and on and on and on. So eventually they had a proc that ran in a minute and a half, right? Rather than one that ran in half a second. Now, what was scary about that is that when we did tracing for an entire week, I didn't find anything ever passed except the ticket number. So they had turned every call to that proc into a minute and a half for a scenario that never occurred, right? Don't fall down that path. Now, I see the same thing where people have screens where people can pick any sort of combination or whatever they want, and the assumption from the developer is I cannot optimize that because I do not know what people are going to pick. But when you look at it in the real world, people will pick 2 or 3 things every time. There'll be a handful of times when they pick something else and that's life, right? But you want to make sure that those 2 or 3 things that people pick all the time run fast, right? That may be just a completely separate code path to get to that, but you don't want to be doing the hard work the entire time. Query hints are a pain, right? There are some scenarios for them, but you need to be very careful. And so an example here, in AdventureWorks, I've got a query where if I look at the query plan for this, it runs off and says, look, here's a bunch of things like hash matches going on, right? Now, a hash match is really where it says, look, I need to join these 2 things together, but I got nothing to go on. So I'm just going to start creating hash buckets and throwing things in it, and then try and join the things up, right? But what I see is people go, I know merge joins work better, And now you can get in here and put in query hints to do that. You can even do this. You can say inner merge join, right? And so on. But a merge join requires sorted inputs, right? So if you look at the query plan for that, yes, it'll do merge joins, but look, it'll end up sorting all the data before it shoves it into the merge join, right? And often that'll be the most expensive thing in the whole query, is doing all these sorts. There's a reason they have a hash match plan in the first place. And what's worse is if you look at the entire comparison, you've then taken something here, this is 21%, and the other one, simply by adding our hint to make it better, you're talking about something that now runs 4 times slower, right? So you don't want to go there, right? Now, there are scenarios where you're going to add query hints. Now, what it needs to be is a situation where you know something that the optimizer doesn't, right? So, for example, if I pass a lump of XML in and I use the nodes method, it has no clue how many rows are there or how many nodes are inside that. It guesses, and it will guess wrong real big time sometimes, right? Because it's got nothing to go on. Now, that's a scenario where you know something it doesn't. Now, you still may be better to take that data, pump it into a temporary table, even though I said try and avoid them, and then join off the temporary table because you get appropriate statistics and things at that point. But that's an example of something where you know something it doesn't. The other scenario is where there's a simple bug in the product, right? So you may come across some scenario where it just doesn't work the way you'd expect it to work, or the way it should work, right? Now, the thing about those is they tend to be temporary, those sort of issues. So if you're planting query hints into your code, you need to be documenting why it is there, and you really need to be committing yourself to go back and revisit every time you do an update to see if that scenario still applies, right? Otherwise, what you may be doing is detuning your system over a period of time. Indexing isn't a job for somebody else later, right? So I come into sites all the time where there's just an amazing amount of coding going on, but when you start talking about indexing, they say, we didn't get to that yet. They're like, yeah, okay. And look, that's simply not reasonable to be in that state. And so you need to be looking long and hard every time you write a query that is going to run for any length of time. You need to be thinking about how is this going to get executed. I mean, learn something about indexing, learn to read query plans, and start to get a little comfy with this. It's not that hard, really. It's not that bad. Obviously, as queries get more tricky, it does get tricky, right? That said, don't go adding everything that the dynamic management views add or suggest, right? We do have sysdm missing index views. Now, the problem with those is that they tend to make suggestions that they'll give you a hint that there's a problem there, but the logic they're using for coming up with the indexes is not all that great, right? I mean, it'll give you an idea there's a problem in and around that area. The worst scenario I've seen for that is I went to a site where they had the slowest system I have ever seen in my entire life. And I went into Object Explorer in Management Studio and I expanded out the table. And then I went to look at the indexes, and as I opened it up, Object Explorer exceeded the memory limit. They had more indexes on a table I had ever seen in my entire life. And what it was is they had written a job that started up every 15 minutes and had a look at any missing index and created it. But they forgot to check if they had already done so. And so, simply awesome work. The other one is, of course, optimizing for small or skewed data sets. And so it's pointless sometimes going and building the indexes and so on if you're working with unbelievably small amounts of data compared to the real one. The other one, of course, is you may have masked or processed data in some way, and it may be completely unrepresentative of the real data. Now, one thing that is worth investigating is you can export the statistics from larger systems, and you can import them into the development machines, and then you could have the query you'd need to turn off auto stats and stuff, but if you do that, you could kid the optimizer into thinking it had the real data, right? And even though it doesn't actually have it. So that's another little trick to look into. There's some things online to show you how to do that. And ping me if you don't know. It's another one I knew I would see one day. I came across an index called name of missing index. That was just awesome. All right, so a couple of final things. So the first one is, look, agile, I think, shouldn't be a synonym for sloppy, you know? I see people using this to say, look, what they're really saying is we had to do this in a really big hurry and we didn't have time to do it right. You know, that's not agile. That's the complete opposite of doing something agile. I've got a friend, Randy Knight. He said actually 95% of his business is fixing performance problems from what people consider agile teams, right? Don't be there. A really big one for me is having at least one layer of abstraction in the database. Now, this is one that some will simply disagree with, but what I find, I go into large enterprises all the time where the people who look after the database feel like they can never change anything. And the reason for that is they have no visibility in the code that touches the database. And so there's T-SQL embedded in reports, entity framework code sitting in the application, there's T-SQL in spreadsheets, there's T-SQL in Power BI queries, there's just stuff. And the problem is that when they go to change something, you know, they know that if they change it, somebody's going to scream at them, but they don't know who it is. So the problem is they very quickly get to a situation where they won't change anything, right? Now, again, that's the exact opposite of agile if you start heading down that path. Now, it is important too to then consider that maybe my logical data model doesn't have to be the same as my physical one. So if I decide that I'm using GUIDs all through my entities at a higher level, that doesn't mean that those same GUIDs have to be used right throughout the database, right? If I'm going to build all my tables and join all of them on the GUIDs, it's going to perform badly. Also, every one of those tables, if it has a lot of activity, is probably going to end up incredibly fragmented, right, when you do that. But it may be that the external thing needs a GUID, but there's nothing to stop me having a table that says, you know, that GUID is that number, you know? And then joining all the tables from that point on with the number. from that point on. It doesn't have to be the same thing in all the layers. AdventureWorks, I've got to throw in a mention. I see people all the time say, but it's in AdventureWorks, right? I can only say to you, I don't consider it represents best practice. And the thing about it is it's probably the least typical database on the planet. And the reason for that is, when did you last build a database that used every single feature of the product? Now you can imagine how much you've got to force fit that in to get to the point where every aspect of the product is used. That's not going to lead to something that's a fairly typical database. So there's a lot of very, very forced decisions in there. Also, online advice. Unfortunately, there's a lot of stuff online that's simply wrong. A big part of this as well is that it ages quickly. It's just one of those industries. And so there are things that were 100% correct a couple of years ago that are 100% wrong today, right? And so you really need to particularly look at the age of any advice that you're picking up. But it also encourages you to think about having somebody that just spends their life with data on the team. I come across, again, many development organisations where they'll have a very large number of devs, yet almost everybody is a clone of each other, in some way, or at least they won't have somebody focused on data, right? And so, but yet most of these apps they're building will be data focused, right? It's not the time, when you're getting towards shipping or something, to start getting a data person along to work out what's going wrong, right? It's just not the right time. To give you an idea of the sort of requests I get, I was at a site recently where they've been building an app for 4 years, right? When I talked to the business owner, they told me they needed to get to 1,000 concurrent users for them to be in a position to have a viable business. 500 concurrent users would get them to some sort of break-even point. 3 weeks before their shipping date, they couldn't get past 9. Right? This is not reasonable, right? And it's then, please help. That's hard, right? That's really, really hard. Also, don't go building things that are already in the product, right? Again, I see people building queues, yet there's a transacted queue sitting in the database, right? Use those things. Service brokers are a wonderful thing, but so very few people have wrapped their head around it. Now, it's not their fault. I know when the product was shipped, it was almost invisible, no tooling, no guidance, yes, I understand, right? But it was awesome work that was done there. But that's still always going to be a mile better than you going off and starting to build your own queues in tables, by a long shot. Because they will have thought of things that you have not thought about. Like, what do I do with poison messages? What do I do with... Somebody's thought through that stuff, right? Don't go and redesign it yourself, because you'll get it wrong. Security, if you're designing your own security, that is almost invariably a bad idea, unless you are Microsoft or Google or somebody, right? You just won't get it right. And it's too risky to get it wrong. All right, you need to also keep it safe. Now, the most common problem I see with this is, of course, apps that connect as DBO or some sort of SA user, this sort of thing. This is scary stuff, right? I don't know if Corneliu's here this week or not, but guys like that, you just need to sit and watch them trample over your app, and then you'll sort of understand why that's not a good idea, right? What you need to do, even if I look at why people do this, it's invariably because they want to run the app, but they want the app to be able to do database changes and things like that. Don't do that, What you need to do instead is have 2 separate parts of the app. One that you run as an admin person that does the admin stuff. The rest has a very constrained interface in terms of what it does. And that's the only one that a user should ever get near, right, in any way. If I have things that are exposed to websites, I'll always create a separate schema. Just for that website, I will create a user that only has permissions on that schema, and I won't let them near anything else. You know what I mean? You just really want to corral this stuff as tightly as you can. You do not want to let the app get to any other sort of parts of the application at all. Now, systems get trampled on all the time. You know? People don't talk about it, but they still get trampled on all the time. In fact, there's a large global charity that got trampled on about 2 years ago. You know? And what was interesting is that they were nearly 3 months without being able to take a donation. If you're a large global charity, you think about what that means, right? Now, of course, they never talk about it because otherwise nobody would give them money, right? But it took a team of people, and volunteers, a whole lot of us, trying for months to get them back up. Because when you looked at the problem, it was endemic throughout the code. The day you have a problem is not the time to start thinking about how to fix the security. But you can guarantee the management will want it fixed by tomorrow morning, right? And just as important as writing code is ripping it out, right? One of the things that you need to have is some process so that you're endlessly looking at the code you're building and try and work out how to refactor it, to rearrange it, how to rip code out and use newer things that are added to the product to reduce the size of your code base all the time. Otherwise, you're just endlessly building a sort of a bigger technical debt when you do that. And so it's just as important to have people ripping code out as it is to have people building new code, although the focus is often on building new code. And so look, I'll be around in the demo area for the next little while. I thank you very much for coming along this afternoon, and feel free to pop up and ask some questions. It's all good. Thanks, folks.